Chemistry, we're on to our next lesson in the Electrochemistry and Redox Reactions unit, and this is on electrochemical cells. So electrochemical cells physically break two half reactions of a redox reaction into two different cells. Physically, they're separated and they're connected by a wire. So electrochemical cells are simply batteries which use chemical reactions to produce electricity. So that's what we're talking about here, is how a battery works. For the redox reaction to take place, the electrons will need to flow through the wire from the zinc to the copper. So we know that the copper is going to pull the electrons away from the zinc. That's what the activity series tells us. And in this case, they're going to have to move through that wire. This is how a voltaic cell works. This is also known as a galvanic cell. So voltaic cell, galvanic cell are both the same thing. The cell on the left in the diagram below contains a zinc metal strip in a solution of zinc sulfate. That's ZnSO4. Zinc sulfate will dissolve in water, leaving Zn2 plus and SO4 2 minus ions. So you can go check your solubility rules and verify that fact. The zinc metal is oxidized because the oxidation number increases from 0 to +2. It will release 2 electrons to the copper. So the oxidation is losing electrons. The strip that releases electrons is called the anode. Now, I always found this a little confusing because I think of ionic bonds and they have anions. And what is the anion? It is the nonmetal that took in an electron and then after that formed an ionic bond. So an anion takes in electrons, but an anode releases electrons. So it's the opposite of an anion. Anions take in electrons, anodes release electrons. So just kind of keep that distinction in mind. The container holding the anode and the ZnSO4 solution is called the anode cell. The cell on the right in the diagram below contains a copper metal strip in a solution of copper sulfate, CuSO4, and CuSO4 will also dissolve in water to form copper 2 plus ions and sulfate 2 minus ions. The copper Cu2 plus ions are being reduced because their oxidation number is changing from +2 to 0, and that's an electrically neutral atom. The strip that takes in the electrons is called the cathode. The container holding the cathode and the copper sulfate solution is called the cathode cell. Okay, so now we're going to see how an electrochemical cell works. So over on the left you have the zinc strip in the zinc sulfate solution, and over on the right you have the copper strip in the copper sulfate solution. So the anode cell contains a charged solution of zinc ions and sulfate ions. The cathode cell contains a charged solution of copper ions and sulfate ions. Now, a zinc atom, you see one in a red box there. The zinc atom in the anode, a zinc atom in the anode oxidizes 2 electrons. So let's watch that happen. It's going to oxidize. That means it's going to lose 2 electrons. So there goes one of them. It's going over to the copper, which is going to be reduced. It's gaining the electrons. And there's a second one. Now what happens is that zinc atom is no longer an atom, it's now a zinc ion, so it goes in the solution. So there you see it in a red box over on the left. So this produces a zinc 2 plus ion in solution. Okay, now what happens is one of the copper ions that's in solution over on the right side is going to be attracted by those 2 electrons because that copper strip is now electrically charged. It has a negative charge to it. So it's going to draw over one of the copper 2 plus ions. Okay, so there goes the ion over there, and now that copper ion is going to accept those 2 electrons. So the 2 electrons in the cathode attract and bond to the Cu2+, and that turns it back into an electrically neutral copper atom. And so there you see it right there. It showed up as Cu over on the right side. It's electrically neutral, and it becomes a part of that strip. Now this sequence will repeat. There goes 2 more electrons from another zinc. That zinc is being oxidized. Second electron goes over and reduces. It joins the copper strip, turning it negatively charged for a moment, but then another one. Well, first of all, the zinc is then going to go into the solution as a zinc 2+ because it lost the 2 electrons. And that those 2 electrons are going to draw one of the copper ions, the Cu2+, over to it. So there's the copper 2+. It's going to go over. It's now going to move over there. And those 2 electrons are going to join the copper 2+. It's going to become a neutral copper ion, atom, and it's going to metallically bond to the copper strip. And there you have a neutral, electrically neutral copper atom that's metallically bonded now to the copper strip. One more time this is going to happen. There's a zinc down there in the red box. It's being oxidized of 2 electrons. There they go. And the copper over on the right is going to be reduced. First they jump onto the strip. Now, first of all, that zinc atom, which is electrically neutral, now has a +2 charge. So it's going to be repelled out into the solution, and it's going to join the solution. Over on the right side, the copper, another copper ion, is going to come over, collect those 2 electrons, and become an electrically neutral copper atom, and that process continues. Okay? But there's a problem. You have electrons flowing only in one direction. Electric circuits require that there be a flow in a complete circuit. You can't have electrons going from point A to point B like this, from zinc over to copper. There has to be a complete circuit for electricity to flow. And not only do you need a complete circuit for the negative charges, the electrons, you need a complete circuit in the opposite direction of the positive charges, which would be protons. So let's see how that works. So a salt is a neutralized acid base. We learned that in the acid and bases unit. So Cl- is the conjugate base of hydrochloric acid. Cl- can be neutralized by ionically bonding with a positive ion such as a potassium plus ion to form KCl, potassium chloride. So KCl is a neutralized conjugate base of hydrochloric acid, and what we know about it is it's going to dissolve in water. So solubility rules indicate that KCl will dissolve, producing potassium ions and chloride ions. A salt bridge contains a salt that will ionize in water and carry electrical charge. So when you have those positive and negative ions in a solution, they will attract and repel electrons, and they will allow electrons to flow. That's what you need to get electrons. Electrons will generally will not flow in pure water. They only flow in water where there's impurities, positive and negative charges. In this case, the impurities are the potassium and the chloride. So that's going to allow electrical charge to flow. So the chloride ions will move to the anode cell to neutralize the buildup of Zn2. So you remember the Zn2+ was building up over there as the zinc was being oxidized. So now these chloride ions are going to start coming over there to neutralize that. An electrochemical cell must remain electrically neutral at every point along the way. So you must have as many negatives as positives in an electrochemical cell at any point along the way. However, they're constantly moving, and so that you have to have things constantly changing here. So here comes another chloride. So it would actually take 8 chlorides to neutralize those 4 Zn2+. I'm not going to show all 8, but you just understand that negative charges are coming down to neutralize those positive charges down there in the anode cell. Now the potassium ions will move to the cathode cell where there is a buildup of SO4 2- of sulfate ions. So here they go. Here goes a potassium. It's a positive charge that's going to keep the solution electrically neutral over there on the cathode side. There's the fourth one. Again, I'm not trying to match them up number for number. I'm just giving you the idea of what's going on here. So electric charge must flow in a complete circuit, both the negative charge and the positive charge. So let's see how that happens. So the negative charge flows from the anode to the cathode. We already saw that happening with the electrons. So it's going to come up through here, and the electrons are going to move along as we saw them do before, and they're going to come down here to the copper strip. Now the copper strip has a negative charge, so what's going to happen is the negative charge then is carried by the SO4 2- ions in the solution and up the salt bridge attracted by the potassium ions. So you're going to see them come down, and they're going to start climbing up while the potassiums are climbing down. Remember, there has to be equal positives and negatives at any point along the way here. So there goes the SO4 2-. Next, the negative charge is then carried by the chloride ions, as we saw on the last slide, in the salt bridge into the anode cell attracted by the zinc 2+ ions. So there goes the negative charge, and at the same time the zinc 2+ ions are climbing up the salt bridge, and they're meeting with that. So now the negative charge is then carried by the SO4 2- ions in solution over to the anode. There it goes. And finally, the negative charge is then carried through the anode as zinc is oxidized to produce more electrons. So you see the negative charge went all the way around from zinc and ended up back at zinc again. Positive charge must flow in the opposite direction. So let's see how that works. So the positive charge flows from the anode to the anode cell when Zn is oxidized to form Zn 2+ ions. So you see all the Zn 2+ down there on the left side in the anode cell, so there it is. Now the positive charge is then carried by the Zn 2+ ions in solution up the salt bridge, attracted by the Cl- ions. The positive charge is then carried by the potassium cations in the salt bridge down into the cathode cell, attracted by the sulfate ions. The positive charge is then carried by the copper ions in solution over to the cathode. The positive charge then moves from the cathode through the wire back to the anode to complete the circuit. So there you see the positive charge is going in the opposite direction, coming back to where we started at the anode. Okay, so we said that positive charge must flow in the opposite direction, but how do the positive charges move through the wire? We know that positive charges are protons in the nuclei of atoms, and they can't move. They're stuck in the nucleus. They can't flow the way electrons can flow. So how do we get positive charge to move? Well, nature thought of a kind of a tricky way of having this happen. Holes represent atoms missing one electron in its valence orbital, where a positive charge exists on the atom. So there you see a circle over on the right side that has nothing in it. It has no electron. That represents an atom that lost an electron, that moved towards the cathode, toward the copper. And so it has a positive charge. It represents a positively charged atom. Now that atom is fixed, and so are all the other atoms in the wire. So they're fixed. They can't move. The protons can't move. But watch what happens. We're now going to have that electron move over towards the copper wire, the one that's the first one on the right, and it's going to move over to that hole. So although the protons are not moving, the positive holes move in the opposite direction of the negative electrons. So here goes that electron. There's a hole, and that electron's going to move over there. Now look what happened to the hole. The hole moved over to the left. Now the next electron's going to move over to that hole because it's attracted by the positive charge and by the cathode as well. So it's going to move over there, and now the hole moves to the left. So notice that the positive charges, as this process repeats, continues to move to the left. They're not actual protons moving. The protons can't move. But the positive charge, which atom has the positive charge on it, continues to move to the left. And so the holes effectively are the positive charge that's moving over to the left until it gets back to the anode where the zinc is. And that's how positive charges can move throughout a circuit. This is how positive charges move from right to left, even though no protons move. All right, and that takes care of our lesson on electrochemical cells and how batteries work.